says evaluate 2x minus y over 3z for x equals 3, y equals -1, and z equals -4. So we're going to plug in, we're going to put parentheses for each variable, then we're just going to be very careful about which variable goes where. So x equals 3 goes in the first spot, y equals -1 goes in the second spot, and z equals -4 goes in the third. So we end up with 6 plus 1, because minus a negative makes plus, over -12. And that gives us 7 over -12. Now because I don't like my negative in the denominator, I'm going to switch that to -7/12. As long as you know that there's only one negative sign, it doesn't really matter which way you write it. Okay, let's go on to number 21. On 21, we are adding, looks like, two polynomials. We have x squared minus 7x minus 2 plus 3x squared minus 7x plus 5. So we're going to combine our like terms. We have x and 3x squared, or x squared and 3x squared, excuse me. That gives us 4x squared. Then we have -7x and -7x, which gives us minus 14x. And then we have -2 and plus 5, which give us plus 3. So there's our answer. Now in the next one we're subtracting. We have 2x squared plus 2x plus 1 minus the quantity x squared minus x minus 4. Now what we need to do is we need to distribute the minus sign to the second set of parentheses. So we get minus x squared plus x, because minus a minus gives us plus, and then plus 4 for the same reason as the plus x. And then we write down the first terms. And then we're going to combine our like terms. So we have 2x squared and -x squared. And that gives us positive x squared. And then we have plus 2x and plus x, which gives us plus 3x. And then we have plus 1 and plus 4, which gives us plus 5. Now number 23, we have 8x squared minus 4x plus 1 minus 10x squared plus 4. Now again, because it's minus in between, we have to distribute that minus sign. So we get minus 10x squared minus 4. And the first one we just write down the way it's written. And then we combine our like terms. 8x squared minus 10x squared gives us negative 2x squared. The negative 4x doesn't have a like term, so it just comes down. And then we end up with plus 1 and minus 4, which gives us minus 3. So that's our final answer, and I forgot to box my answer on this one, so I'm going to box it. Okay, for number 24, it says subtract 8a squared plus a from 6a squared plus 2a plus 1. So when it says subtract one thing from another thing, that means this comes first. So we're going to rewrite it as 6a squared plus 2a plus 1 minus the parentheses 8a squared plus a. Now, again we have minus, so we distribute the minus. And we rewrite the first set of parentheses stuff. And then we combine our like terms. 6a squared and minus a squared give us minus 2a squared. Plus 2a and minus a give us plus a. And then we have the plus 1 left over. So there's that one. Now on to number 25. 25 asks us to find the area of a rectangular field which is 55 meters long and 37 meters wide. So 55 meters long, 37 meters wide. Area is length times width. So we're going to plug in our length is 55 meters. Our width is 37 meters. We're going to multiply those two things together. And we're going to get the area is 2,035 square meters. And I write it like this, but you could also write 2,035 SQ meters. So either one of those is correct. Remember, you do have to remember your formulas. Okay, the next one, number 26, asks us to find the exact circumference and the exact area of a circle with a diameter of 17 inches. So we have a circle. The diameter's all the way across, and it's 17. We want to find exact circumference, which means we leave everything in terms of pi. So circumference is equal to pi times the diameter. And we'll go ahead and write down the area formula for the other part. It's pi radius squared. And And so the circumference in this case is just pi times 17, which is 17 pi inches. The circumference, very simple, very straightforward. Now, for the radius problem, we know the diameter is 17. Remember, radius is only halfway across. So the radius is 8.5. Let's try that again. The radius is 8.5 inches. So we're going to be plugging in 8.5 inches into the radius spot. So we have to square 8.5. And that gives us 72.25 pi square inches is our area. Now remember, we leave the pi because they said exact, so we're leaving it exact. If they had said approximate, we would approximate, which is what we're doing on the next one. So I'm going to move this up. Hopefully I can do the next one with my formula still showing. Now we have the circumference and area of a circle with radius of 7 inches. And we're using pi is approximately equal to 3.14. Whenever you're approximating, they're going to tell you the approximate value of pi. So circumference is pi times diameter, area is pi radius squared. So for our circumference, we need to get the diameter. So if halfway across is 7, then all the way across is going to be 14. So the circumference equals 3.14 times 14. Actually, it's approximately equal to, because that's not exact. That gives us 43.96 inches for our circumference. So that's our approximate circumference. Now we're going to do our approximate area, so we're going to put in 3.14. Our radius, which is 7. Now we always do the 7 squared first, and then multiply by 3.14. And that comes out to, and again we're approximately equal, I keep messing that up, 153.86, and it is square inches, because area is always square units. So our approximate area is that. So there goes that one.